Okay, so this is the Unit 1, Grade 7 practice assessment. First things first, this should be the 717 or 7/15ths. Sorry about that, the 7/15ths. Okay, so we're going to be filling out this table and filling out the decimal form, percentage form, and fraction form of various given things. All right, so first thing, we're going to take this 7/15ths and turn it into the decimal form. So let's go ahead and do that right away. So I'm going to take a sticky here, and we're just going to do it on a sticky just to save some room. All right, so we're going to take 7 here, and we're going to divide it by 15. All right, so this obviously 15 doesn't go into 7, so put a 0, and then turn this into 70. All right, so how many times will 15 go into 70? Well, let's try like a 4, because I know it'll be 60 at least. All right, so 4 times 15 is 60. There'll be 10 left over. Let's bring down a 0, and now it's going to be 100. How many times will 15 go into 100? How about 6? Because 6 times 15 is 90. 90. All right, so we have a 10 left over, and you can see now, right, that it's going to be repeating itself, right? So how many times will 15 go into 100? Well, it's going to be 6 again. Okay, so this is going to be 4.66666666 repeating, and if you want to check yourself, well, you're not going to be able to, but you can see that 7/16ths, 7/15ths is indeed fraction decimal is indeed 1.7/15ths, excuse me, 7/15ths is 4.66666 repeating. So it's 0.466 repeating. Okay, and then the percentage is 0, or the percentage will be multiplied by 100, will be 46.66% repeating. Okay, then this decimal here is 0.65. The fraction is going to be 65 over 100. You can divide both by 4. And 65 is not divisible by 4. Let's divide both by 2 here. 65 by 5, excuse me. Let's see. That's going to be 13. 13 and 100. I'm sorry, 13 and 20 and 20. Okay, and then the percentage is going to be 65%. Okay, then moving on to this one, the decimal form of 56% is 0.56. The fraction is 56 over 100, and you can reduce that. Let's see, that's going to be 28 over 50. We're reducing that even more to 14/25ths, and that's pretty much the most you can reduce that. All right, so here is another question. Let's zoom out a little bit on this one, and we have some people. This should be a he. Sorry about that. Looks like that mixed that one. He, raising P. This would be a Stephen. Sorry about that, Stephen. Okay. So how we do this? Okay, let's identify our givens. Okay, and then figure out what our variable is in our equation. So we're going to let, and then we're going to name some givens and some variables and some terms in this. Okay. Stephen is saving his money for a trip to Jupiter. Great. Every week he sets aside the same portion of his paycheck. Okay. So paycheck, taking out $128. So we're going to say we're going to let we'll say money. We'll just call it money out or money saved. Money, no, that's the weekly expenses. So money expenses, okay, is the expenses out of paycheck, Okay, after 7 weeks. So T equals time, and it equals 7 weeks. Remember, we have $128, also known. And then the money total, T equals total saved. And that just happens to be $759. Okay, and then it's going to figure out the amount of time, the amount of dollars X he earns each week. Okay, so let's figure out like what the total amount of money, the total amount, so the dollars total would equal. Okay, well, we know that each paycheck, X, okay, because X equals paycheck, it's the dollars per paycheck, right? Let's replace that as X equals dollars per paycheck, okay? It minus the dollars that he sets aside for the expenses is what he gets set aside each one. That equals $128. Okay, so and we know that, or after taking $128 away, he knows that after taking out $128, he's going to have whatever's left over. He saves for the trip, and he did that 7 times. Right, so he gets his paycheck, takes out $128, and after 7 weeks, the time, he has a total amount of money. Okay, so what we're trying to solve for is this variable X. Okay, so we're going to rearrange the equation. You could put this up here, that's the equation, but you could rearrange it first to solve for X. So the first thing we got to do is divide both sides by T. Okay, so divide both sides by T is going to be the dollars total that he saved divided by the time. Okay, and that's going to make this go away, right, because you divided the entire thing by time, right? So that's going to go, so let me show you that more closely. Right, so if this is divided by time, you divide this by time, okay, the times cancel out, okay, and I'm sorry, the time doesn't cancel out on this side, but the time cancels out on this side, so I'm left with the dollars divided by the time equals what's left over here is X minus the dollars that he sets aside for expenses. Okay, so now just to get X all alone, I have to add expenses to both sides. So if I add it to this side, it goes away. And if I add it to this side, to balance the equation, so it's $1 of expenses. So this is what X equals, also known as the expenses out of pocket. Right, so that was just some algebra. This original equation can be rewritten to equal this equation. So my X equation equals the dollars total that he saved divided by the time plus the dollars of the trip, or of that he expenses pay out of the expenses out of his paycheck. Okay, so that is how that is all done. Okay, so now let's just plug in some numbers and we will get what he gets per paycheck. All right, so we're gonna do this. We'll put in let's see, $759 divided by 7 plus $128. So 759 divided by 7 ends up to be 108.42. Round it up to 43 because it's cents. 43 because you round up in cents, and then plus $128. So plus 128, and that ends up being $236, $236.43. So that's the answer to that one. Okay, moving on to this one. Okay, so we're doing cherry cola. So cherry cola, percentage of the package is cherry cola. Okay, so a bottle caps has these flavors. And oh, I didn't I didn't change all these. This is supposed, so ignore all this. This isn't the final version that I came up with. That's why I had all those errors. All right, so just this is the flavor of all these things. So what is the percentage of cherry cola in the package here? All right, so this is 12%. All right, just move this over 2 and multiply by, that's multiplying by 100. That's 12% for cherry. Okay, it's the root beer. What's the decimal for the root beer? Okay, so you have to do 15, or 4 divided by 15. Let's make some more room. So 4 divided by 15. Well, 4 won't go into 15, so you have to divide it by 40. So like 2 will go into that, so that's going to be 30. Subtract it, that's going to be 10. Right, so that's not going to work. You bring down the 0. 15 will go into 100 like 8 times, I think. Nope, 6 times. 90, yeah, 6 times. 90 times. So it's going to be 10 left over. And you can see that there's a repeating pattern of 100, so it's going to be just 6 repeating over and over and over and over again. So the decimal is going to be 0.26 repeating. Okay, the package of orange is 0.2 repeating. And remember, the thumb rule is if there's one number repeating, divide it by 9. Divide that number by 9. If there are 2 numbers repeating, divide that number by 99. If there are 3 numbers repeating, divide it by 999. Okay, and I'm going to show you the reasons for that, but this is the thumb rule. That's the thumb rule. So this has 1 number repeating. So we're going to divide 2 by 9, and that's my fraction. And there's no way to reduce that. Okay. The amount of cola D, or the amount of cola written as a decimal. All right, so that's 0.2 written as a decimal. So 0.2 is, or 20%, sorry, that's 20% written as a decimal, so that's 0.2 written as a decimal. All right, so that's the first few. Let's move on to number 3. Yeah, number 3 here. Okay, so a couple ways to do this. I'll show you both. Okay, first one is I'm going to multiply both sides by -2 here. Oh, sorry, divide both sides by -2. Right, that gets rid of the -2 right there, and it's going to turn this into -13 on that side, leaving this side x plus 4. Right, so now to get x all by itself on this side, I need to subtract 4 from this side, leaving that to be 0. Since I did it to this side, I had to subtract 4 from that side, so I'm going to have x equals -13 minus 4 is -17. That's one way to do it. Other way to do it is to distribute this -2, so -2 times x plus 4 equals 26. So I can distribute the -2 into the parenthetical polynomial here. All right, so I'm going to do -2 times x. Remember this -2 applies to every mathematical function every time you multiply it. So it's going to be -2x, -2 times +4 is going to be -8, right, equals 26. All right, so now I'm going to get this negative, and this -2 is my variable term, so I want to get this 8 out of this expression by adding 8 to that side and adding 8 to that side, because I got to keep it balanced. So that turns it into 0. 26 plus 8 is 34. So I have -2x equals 34. I have to divide both sides by -2. That's the coefficient of my variable term, making this x equals -17. So that's that one. All right, moving on to this one. Okay, The first one is easiest to do here is just to move that, get rid of that constant term on my side that has a variable all by itself. So I'm going to do that by subtracting 5.7 on that side. Since I did it on that side, I have to subtract it from that side as well. Right? So that's going to make this 0, and then negative 9.3 minus 5.7 ends up being negative 9.3 minus 5.7. Pretty sure it's 15. 9.3 negative minus 5.7 negative, or yep, negative 15. I thought so. Negative 15. Okay. Equals, move that equals sign, equals x over 4, and that's negative. Okay. So you can move that x sign. You can also write that, by the way, as negative 1/4 x, if that helps you. All right, so now I need to get that x to become just 1. All right, so in order for that to become 1, I need to multiply it by the coefficient, or divide it by the coefficient of the variable term. All right, so dividing it by the coefficient of the variable term is dividing it by the 1/4, which is also multiplying it by 4, which, if you just want to think about it, by multiplying by 4, that also makes more sense to most people. All right, so I'm multiplying it by negative 4. Multiply both sides by negative 4. Right, so that cancels out, that flips it to positive. Right, and then that's going to make this negative 4 times 15 is going to be 60. So x equals 60. Moving on to this one. Okay, so here we go. We got this one, and we have, well, I can tell already that I'm going to have to subtract or add two terms that have a different denominator. So let's go ahead and take a look at this. First, I need to just kind of isolate my variable state, my variable term. So I'm going to get rid of this one on my variable side. Expression. So I'm going to subtract 3 3/8 from that side. So it's going to be 2 4/7 minus 3 3/8. Now I'm going to have to turn these into improper fractions, but before I do, I'm just going to, like, if I do 2 4/7 and 3 minus 3 3/8, I'm just going to, like, do the big numbers first. I'm going to get negative 1, and then the fractions are going to be left, right? So it's going to be negative 1 3/8, and then the 4/7. It's going to be all by itself, okay? So let's get rid of the fractions, the big numbers. So I got rid of this one, and I got that one left, and I'll have a 1 in front of it. All right, that's going to help me. That's going to help me with turning these into improper fractions, especially if I'm not using a calculator. Okay, so now this, and by the way, this equals negative k. All right, because this is the hardest part about this whole problem. Right, so in order to find this and turn this into an improper fraction, I need to make these common denominators. Okay, least common denominator is preferred, but it doesn't necessarily have to be. All right, so I'm going to multiply this by 8 over 8. This is 1. 8 over 8 is 1. I'm going to multiply this. Well, first I need to convert this into a fraction. So I'm going to do that right here. Okay, I'm going to turn this into a improper fraction. So 1 times 8 is 8, plus 3 is 11. 11 over 8. So that's minus 11 over 8. Right? So I'm going to change this into 11 over 8. 11 over 8. Okay, and I'm going to multiply this by 7 over 7. Okay, so now I'm going to, 8 times 4 is 32/7 minus, it's going to be 77 over, sorry, not 7, that should be 7 times 8 is 56. 56, and then 77, 56. Now, since these have the same denominator, I can add or subtract the numerators, because before I couldn't, because I couldn't add and subtract these fractions because they were different denominators. This still equals negative k. All right, so 32 minus 77 is negative 45.56 equals negative K. Let me double check that. 32 minus 77. Yep, negative 45. And then, therefore, K equals 45.56. 45.56 is, whoa, 45.56 equals 45.56 is not reducible. I didn't think so. 45.56. Okay, so that's through 5. Here's number 6. Working at Shuckers, and he makes $11 per hour. There's a rate. This is my pay rate. Rate of pay equals rate of pay and it's $11 per hour. My pay and tips is pay and tips, and then my total pay total wants to earn $256. $256.14. That equals pay total. TOTAL. And then my pay from hours equals my pay from my rate of pay times time, right? Rate of pay times time. So my pay total is going to be equal to my pay from tips plus my pay from time, right? But my pay time, this should be pay from time, not pay from hours. Let's change it to pay from time. Pay from time. That works. Okay. Pay from time. All right. So now I can substitute my pay rate and time for my pay from time. Okay. So my pay rate, so my equation is going to be my pay total, my total pay equals my pay from tips plus my pay rate times my time, and the time is what the question is asking me. It's the number of hours I gotta work to make that much money. Okay, so I gotta solve for this. Okay, so to solve for this, I gotta subtract, I have to subtract this from both sides. Okay, so I'm gonna have pay total minus my pay from tips equals my pay rate, my rate of pay, minus or times time. Okay, so now I need to divide both sides by time, or sorry, by pay rate, rate of pay, and now I have my time equals that. Okay, my time equals that. So I'm going to transpose that up here. Time equals my pay total minus my pay from tips divided by my pay rate. And when you throw in your units and stuff like that, it should make sense. So let's do that. Okay, so my time equals my pay total is $256.14 minus my pay from tips, which was $97.50 minus $97.50, and I can do that because that's $. Minus $. Okay, and then divided by a pay rate. So a pay rate is in dollars per hour, right? This is dollars per hour, so I can do $11.20 per hour when the denominator of a denominator is the numerator. Okay, so per hour. So I end up with hours. Okay, so I can just do 256.14 minus 9750 equals divided by 1120, and that should equal, I need to work 14 hours. I need to work 14 hours and 0.16 hours. 14, so it's like just over 14 hours and 15 minutes. Why did I put dollars there? 14 hours, 0.1, and then remember each one of the like 0.1, like no, that's not right. 0.15 hours, 0.25 hours is 50. This is like 12 minutes, right? So 0.14, 0.16 hours, so just a little bit over 14 hours. That's the correct answer. All right, so moving on to inequalities. Inequalities. So key things to remember, they're just like solving equations, except there's one major thing you need to remember, okay? Is you have to flip the sign, like this sign, the equality sign, or the inequality sign. Flip the inequality sign, equality sign, S-I-G-N, when you multiply or divide both sides by a negative. Okay, so like here's an example. All right, so first things first, you need to isolate the variable term. In order to do that, and this one, the easy way to do that is subtract negative 6.8 from both sides. Okay, so that means this is 0, and then the other side is going to be 36. So it's going to be negative 12x is greater than 36. So then you divide both sides by negative 12. By negative 12 to get rid of the negative 12. Since you divided both sides by negative 12, the first thing you do is flip the sign. Okay? 36 divided by negative 12 is negative 3, and then you have x left over. So your x is less than or equal to less than negative 3. Okay, so you have negative 3, and your x is over here somewhere. That's the answer for that one. Okay? So there you go. Oh, sorry, the sign is wrong. It's not equal to, so it should be an open bubble. Okay? That's there then. Okay? If it's got a one of those signs in it, it's a mark like that. If it's not, doesn't have that, if it's open, it's like that. You should see like a little bullseye on it. Okay? So the next one, you can distribute it or you can divide it by 7. I wouldn't divide it by 7 first because 63 divided by 7 is not, never mind. 63 divided by 7 is 63 divided by 7 is 9. All right, so I'll go ahead and do that. All right, so divide this by 7, divide this by 7, and then you have left 2x minus 4 equals 9. Okay, so isolate the x by itself, add 9 to both sides, plus 5, whoops, that's 0. This is going to be 0, and then this is going to be, let's see, it's going to be 14. It's going to be 2x, I put an equal sign, it should be a greater than or equal sign. Greater than or equal to 14, because I said, why did I do that? It should be 13. Greater than or equal to 13, and then divide both sides by 2, not a negative, so it's going to be x is less than or equal to 6.5. All right, so I find my, I did flip that, I don't need to flip that sign. Is greater than or equal to 6.5. Find 6.5, and then mark it. Just like that. Okay? So x is greater than or equal to 6 point, and notice that it's a solid mark because it has the equal to sign. All right, so I did 10 and 11 first. All right, so here's a couple other ones. Isolate x, add 0.5 to both sides. This makes it, adding this is going to be 23.0 is less than or equal to negative 2x, because I added 0.5 to both sides. So it's going to be divide both sides by negative 2, divide by negative 2, divide by negative 2. This makes it 23 divided by 2 negative is 11.5, and switch the sign is x. Okay, so that is that one. All right, over here, bring the 23 over to this side, or subtract 23 from both sides. So 17 negative minus 23, that's going to give you negative 40, is greater than 2/3 x, or 2/3 x is less than or equal to 40. So I'm going to multiply both sides. It's positive, so no big deal. I'm going to multiply both sides by the reciprocal of 2/3. Okay, so I'm going to multiply both sides by 2/3 of 40. So multiply by 3, divide by 2. That's going to be 120 divided by 2 is going to be 60. Negative 60. So it's going to be x equals negative 60. Like that. I don't even know if I was in camera view for that one. Okay, similarly, all right, I'm going to multiply both sides, the whole thing on both sides, by the reciprocal. By the reciprocal, 4/3. 4/3. Okay, so that gets rid of that. So I have 9x minus, 9 minus 15x is greater than or equal to 18 times 4/3. So 18 times 4 divided by 3. So that's going to end up being 72 divided by 3, which is 24. All right, so now I'm going to bring this 9 over by subtracting 9 from both sides. So it's going to be 9 minus 9 is 0. 24 minus 9. 24 minus 9 is, you guessed it, 15. So negative 15x is less than or is greater than or equal to 15. I'm going to divide both sides by negative 15. Negative 15, that swaps the sign because I'm dividing by a negative, so x is less than or equal to negative 1. All right, so that is how you solve all these problems. I hope that helped out. I'm going to post this, and I'm about ready to start my next class.